This video is on Unit 1, Chapter 3 on Systems of Equations, Lesson number 2, Solving Systems Using the Elimination Method. So the notes here give you a set of steps to follow for solving by elimination. Step number 1 says to line up the equations. Step number 2 says to multiply one or both equations by a number to result in a variable with the same coefficient. I'm going to go one step further and say opposite. We want opposites. And the reason why we want opposites, opposite coefficients, is so that we can then add. I'm going to be honest, in 27 years of teaching, what I have learned is students do better if they can just add. So if you work on multiplying one or both equations so that you already have opposites, then we can just add our two equations together in step 3 to eliminate that particular variable. Then you're going to solve what's left, solve the remaining variables, and then substitute whatever you get back into one of the original equations to find the other variable. So let's look at example number 2. We're going to start with an easy one. In example number 2, we got 3x plus 2y equals 22, and 5x minus 2y is equal to 42. I want you to look at the y, look at the y's. The coefficients, which are the numbers that are in front, the coefficients on the y's are opposites of one another. One's a positive 2, one's a negative 2. That's what our goal is going to look like. We want one of our variables to have coefficients that are opposites of one another, so that this is an example where we do not have to multiply to eliminate. We are just going to simply add these two together. And when we take a 3x plus 5x, we get 8x. Positive 2y plus a negative 2y is going to subtract out. And 22 plus 42 is 64. Then all we have to do is divide by the 8 so that we can find that x is equal to 8. So that, again, is half of your answer. X is equal to 8. We've got to find the y value. And in order to find the y value, you're going to substitute the 8 into one of the two originals. So I'm going to take the first one just because. No special reason, just because. So now instead of a 3x, it's going to say 3 times 8. 3 times 8 is 24. We are going to subtract the 24, and we get 2y equals negative 2. And divide by the 2, and you get y equals negative 1. So our answer for number 2 would be 8, negative 1. Let's jump down and look at number 4, for example. 7x minus 6y equals negative 53, and 2x minus 3y is equal to negative 13. Now, keep in mind, y'all, that you can eliminate whichever variable you want. It doesn't matter whether we eliminate the x's or whether we eliminate the y's. What I like to do is look at what I've got and see which one I think would be the easiest. I think the y's are going to be pretty simple to eliminate, so I'm going to choose to eliminate the y's. Here's why. If I take the second equation and I multiply by a negative 2, negative 3y times a negative 2 is a positive 6y, which is the opposite of the negative 6y that's in the first equation. So by doing that, I've created opposites on the y's, and the y's will quickly eliminate. So I'm just going to bring down that first equation. I'm going to multiply the second equation by negative 2. 2x times negative 2 is a negative 4x. Negative 3y times negative 2 is a positive 6y equals negative 13 times negative 2 is a positive 26. And then all I need to do is add the two equations together, and you can see that the y's will eliminate. 7x minus 4x or plus negative 4x is 3x equals negative 53 plus 26 is negative 27. Divide both sides by the 3 and you get x equals negative 9. So now that you've got x equals negative 9, to find the y value, we'll substitute that negative 9 into one of the first two original equations. I'm just going to use that first one. So 7x is now negative 9 minus 6y equals negative 53. 7 times negative 9 is negative 63. And then we want to add that 63. Negative 6y equals, that's going to be positive 10. And then 10 divided by negative 6 is not going to go evenly. So we're just going to leave it a fraction. Y equals negative 5/3. So my answer here is negative 9, negative 5/3. And y'all, that's totally possible. Some answers may end up being fractions because not everything can be nice and pretty and perfect. Let me do one more by elimination before I move on to the word problems. And I want to jump to number 7 or 8. Let's look at 7. Number 7 says 5x minus 6y is equal to 3 and 7y is equal to 2x plus 8. So the very first step says to line up the equations. And what you're going to notice here is my two equations are definitely not in the same order. So if we take that second equation and subtract the 2x, so I'm going to subtract the 2x from the left side and the right side. It goes away on the right side. And now it says negative 2x plus 7y equals 8. Now, if you compare that to that first equation, the x's and the y's and the equal sign are all lined up. That's what that step number 1 means. You may have to line things up before you decide what to eliminate and how to eliminate it. Looking at my two equations, trying to decide, do I want to get rid of the x's? Do I want to get rid of the y's? I'm going to choose the x's in this situation just because my numbers will be smaller. So you're looking at the 5 and the negative 2. What can I multiply by so that those x's will have opposite coefficients? Well, luckily one's positive and one's already negative, so that's taken care of. The first equation is going to need to multiply by a 2. The second equation, I would multiply by a 5. The reason why I would do that is because that's going to give me a 10 and a negative 10x, which will eliminate. So you're just trying to figure out how to multiply to get the same number or opposites on those particular variables. So the first equation, when I multiply that, is going to become 10x minus 12y equals 6. The second equation is going to be negative 10x plus 35y equals 40. Now we can just add. So you can easily see here that your x's are opposites. We can just add the two equations together. Negative 12 plus 35 is going to give me a positive 23y. That's a 3. Equals 6 plus 40 is 46. Divide by 23 and we get y equals 2. So from there, I'm going to substitute the 2 into one of the two original equations. I'm going to use the first one again, just because, no special reason. Plug in the 2. So we have 5x minus 12 equals 3. Add your 12. So we're going to add it over here, and we get 15. Divide by 5, and you get x equals 3. So my solution to this one is 3, 2. All right, let's jump down to the next part of our notes here. These are the word problems. This is the application part of this lesson. Where we got word problems. The steps here say to define your variables. What are you trying to solve for? And y'all, if you look at the end of the word problem, that may be where you will be able to find that. What am I actually supposed to be looking for? Look at the end of the question. Step number 2 says set up your two equations using the information given, and then solve the system using your method of choice. So let's look at question number 9. We're going to look at question number 9. Marcy bought a total of 20 used books and 20 CDs during the yard sale for a total of $54.50. If books cost $1.50 and CDs cost $5 each, how many of each did she buy? So when it says to define your variables, it's asking us how many books and how many CDs. So how many books and how many CDs, right? So I'm going to let how many books? I'm going to let books be my X, and I'm going to let CDs be my Y. So I define my variable. In step number 1, define your variable. What are you trying to solve for? So if I go back, I should be able to create two equations, and that's what it's going to take. If I have two variables, I have two things I don't know, then I need two equations to figure that out, to solve that system. Marcy bought a total of 20 used books and CDs during the yard sale. So that lets me know that the total, $54.50. A lot of kids are going to want to go, well, that means that X plus Y is equal to $54.50. That is not what that means. That is not true. Because the X and the Y that we set up, the X represents how many books and how many CDs. So a number of books plus a number of CDs cannot equal money. But my X plus the Y is going to equal 20 because I know that she bought 20 total books and CDs. So the number of books plus the number of CDs is going to be equal to 20. How am I going to get the money? How am I going to get the $54.50 over there on the right? Given that each book costs $1.50. So if I take $1.50 times the X and CDs are $5 times the Y, that gives me money. So those are my two equations. Now, how are we going to solve this? You could easily use substitution here. Or you could choose to use elimination by multiplying the first equation by maybe 5. Either way, it's not going to matter. One thing you do need to understand is if I use substitution and you choose elimination, we should both end up with the same answer because we started with the same two equations. I'm going to use elimination. I'm going to take the first equation and I'm going to multiply by a negative 5. So negative 5x minus 5y equals negative 100. My y's will eliminate. 1.5x minus 5x is going to give me negative $3.50 x equals $54.50 minus 100 is going to give me negative $45.50. And we want to divide both sides by the negative 350. And you should get x equals 13. So of those 20, 13 of them are books. So if 13 of them are books, 13 plus what is equal to 20? Well, that means that there are 7 CDs. You would do the same thing for the other word problems. I do want to set up number 11 for you. Kent has a collection of pennies and nickels with a value of $1.98. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Kent have? So again, what are we looking for and how do we want to set it up? How many of each coin? how many pennies and how many nickels. And you don't have to use X and Y. We can use a P for pennies and an N for nickels. Kent has a collection of pennies and nickels with a value of $1.98. All right. So money's a little different than example number 9. It doesn't say he has this many coins. It tells me he's got the coins all give a value of $1.98. Well, how much are pennies worth? Pennies are worth 1 cent. Nickels are 5 cents for the $1.98. So that's how you have to set up that first equation using that first sentence. It's a collection of pennies and nickels with a value of $1.98. And then the second equation is going to come from that second sentence. The number of pennies he has is. So in word problems, the word is going to indicate equals. So the number of pennies he has is. So P equals 5 less than twice the number of nickels. How do we write 5 less than? The word than is important. Twice the number of nickels. A lot of kids want to say 5 minus, but it's not 5 minus. It's going to be minus 5 because it says less than. 5 less than. 5 is being taken away from something. So 2 times the number of nickels is 2n minus 5. Now this one is set up perfect for substitution, and that's what I would do. I would take the 2n minus 5 and substitute it in for the p. I'm going to go ahead and give you the answer. If you want to take the time to work this out, that's wonderful. But your final answer is 53 pennies and 29 nickels. So you take the time to work that out. I'm going to cut it off here so that the video is not getting too long. But those are your notes for Unit 1, Chapter 3, Lesson number 2.